Now in this lecture, we will learn about all-pair shortest path problem. This problem is very similar to the single source shortest path problem. So before diving into the all-pair shortest path problem, let's quickly recap what is single source shortest path problem. In case of a single source shortest path, we were given a graph and each of these vertices are connected via some edge. And of course, all these edges have some weight. The task is we can start any given vertex and find the minimum path from this source vertex to other vertices. So in our problem, London was the source vertex, and from London we have found the shortest path to other cities. So here you see that our headquarters is located in London. So from London we have found the cheapest path to other cities in which we have. So by using any of algorithm, we can find cheapest path from London to any other cities in which we have branches. Now in case of all pair shortest path, the problem is about finding a path between every vertex to all other vertices in a graph such that the total distance between them is minimum. So let's see the example that we have given in case of single source shortest path problem. As you remember, in case of single source shortest path, we find shortest path from the city of London. But here we will take all cities one by one as a source, then we will find the shortest path from each city to others. Now here, as we said, our headquarters located in London, so we need to find out the shortest path to all other cities in case of single source shortest path problem. But in case of all pair shortest path problem, we have to take all these cities one by one as a source vertex and find the cheapest way from these cities to all other cities. Now if you look at this problem very carefully, so in the first stage we will take London as a source vertex. So if we take London as a source vertex, we can find the cheapest way like this. So we can find this solution by using an algorithm that we explained in case of single source shortest path problem, because all pair shortest path problem is combination of multiple single source shortest path problem for different source cities. Now in the next stage we can take Paris as a source vertex and we can find the single source shortest path problem by using Paris as a source city. Now then in the next stage we can take Rome as a source vertex and calculate the cheapest distance from Rome to all other cities. And then in the next stage we can take Barcelona, and in the next stage we can take Berlin. Now if you examine this problem over here, you can easily see that we are running single source shortest path multiple times. So this can be considered as multiplication of single source shortest path problem. Now here we run any of algorithm which are for single source shortest path problem such as BFS, Dijkstra or Bell-Montfort. So for each source city we run any of this algorithm. So in our case we run this algorithm 5 times because we have 5 vertices over here. So if you look at this example over here, you see that we have 5 cities over here. So we have run single source shortest path problem algorithm 5 times. So first we have run for London, then Paris, then Rome, then Barcelona, then Berlin. So if we count them, you see that it is 5 times. So with this we have completed this lecture in which we have learned what is all pair shortest path problem. So here we have learned that in case of all pair shortest path problem, we are finding shortest path from all vertices. So we are taking all vertices as a source vertex one by one and calculating them using single source shortest path problem algorithm. So hopefully everything is clear about all pair shortest path problem. Now in the next lecture, let's see how the algorithm works for all pair shortest path problem. So see you in the next lecture.